Hi folks, it's me again, Daniel, and I am continuing with my little hobby project of writing my own database. In the first two videos, we set up project and did a basic data structure and did the variable types or data types. And now it's time to actually insert some data into this data structure. But the first thing I have to address is that I made a little blunder here in the data types. In the comments, I actually said that varchar has a max of 8,000 characters and text has a max of 255 characters, which is also wrong, I guess, because right now we're saying 255 characters all the time. So we we write it like this. So that's the data type. So now we have to insert something into those leave nodes. As you remember, we are storing our data in a B plus tree in this class called BP tree, and all the data is stored in the leaves of this tree. So we have to modify the leave node to add some data into it. So here we are at the leave node. You can see it's quite simple. As you can see, I added just this line of code here. A leave node can store more than one element, and or in a leave node or in one node there can be more elements. It's defined by its magnitude. In one node we can have several rows of this database stored. One row is always of the type iData type. So it's just a row is defined by an array of SQL data types. The first element of such an array is always the ID. Since there are several rows in one node, we have to make it a list because we don't know, depending on the magnitude, we don't know how many rows there are going to be, how many elements, how many rows there are going to be. So that's the only thing I changed on the leave nodes. In the BP tree, that's the B plus tree, there we did some more stuff. B plus trees always need a magnitude of minimum 3, so we're gonna check that. We added a table name because one tree is actually a table, so we added the table name. We're saving the table name. Then what else? Then the data structure. It's always a list of data types. It's just row with different data types. We are checking if the data structure and the number of columns that have a name are the same, otherwise there will be an exception. And we store it in the BP in this class. Then get data structure and get column names. These are just regular getters. And we also get the table name. Now we are inserting into the database. So insert row. It's not insert key anymore. It's now insert row. So I renamed it and I get a row, or it needs a row to insert. So first of all, we take the first element of the row and parse it into an int. I could write int here actually and not var, which would make it simpler. Why do I need this row? Because the compiler needs to know what this is before I can actually use it. So I get the key, which is, I could use key, but let's rename it. It's the ID actually, right? It is the ID. Then we use this here and temp ID. Now we need to find the leaf where we want to insert the row, and therefore we need the tree. We need a starting point, which is the root element, of course, and the ID. And when we have the leaf, we insert it. Now let's jump to insert sorted. Here we are. We use again those not null annotations. I like them. I know I don't want too many dependencies, or as few as possible, but those are really, really helpful because you don't have to do all these not null checks in the methods. Yeah. So I really like those annotations. I don't use Lombok here in this project. I don't use comments. Now we are inside insert sorted. It returns nothing. First, we get all the keys from the leaf, which are like all the IDs, which are stored parallel. If we go there, how would we? Because they are stored not only not in the leaf, but in the node. If you look at that, there is a list of integer, and it's the keys because each node has the IDs / keys, but only the leaves have the actual rows. So we are checking the keys and of the leaf, and then we jump to the correct position. With this while loop, we find the right position in the list. Then we add the row on position I. And we also add the key on the position I for the keys. So that's how we insert rows. Let's go back up. Where are we? No. So that's how we insert the row into a leaf. But before we insert it, because that's actually quite straightforward, we need to find the leaf. Let's have a look at that one as well. So if we find the leaf where we want to insert it, we need a node and the key. If the node is not a leaf, it's an internal node. Then we get the right key, and then we go into the children and so on. In this while loop, we actually traversing the tree downwards to the leaf where we want to insert them. This is how we insert a row into a leaf. This is quite straightforward. Then we have new class. It's called table. As you can see, a table has a as you can see, a table has a table name and a table definition. The names of the different columns, it's not row names, it's column names. It's column names. Yes, it's column names. We are defining our table with a table name, the name of the rows, and the data type of the rows. We create a BP tree, as a B plus tree, with the magnitude of 3. Right now we are only using 3 because we try to keep it simple. And we use varchars and translate those varchars into a table name. Then we specify the data structure, and now we are actually having an empty table. But that's just the constructor of this class. This class actually just provides the interface for a table, like insert into, delete from, edit. As you can see, I have here always some like needs implementation. Find row. Okay, is implemented because I needed it somewhere, probably for tests. There you can see the whole interface of this table class. Let's get back into insert into the table. So we have the insert into, and there the row we want to insert, and I created a new class I called inserter. As you can see, this thing does everything in the constructor because it just does one thing, nothing else. It inserts, or at least right now, it just inserts a row into this B plus tree. That's it. We can implement it in the construct quite simply. We don't need to have it somewhere on the stack or in the heap or somewhere else flying around. Does its thing and then gets destroyed immediately. So first of all, we check the dimensions. Let's go there, check the dimension. Is the table row and the data structure length, are they the same? Yeah. If, great. If not, not so great. So does the row actually fit into the table? Then we're checking the data types, so that the row we want to insert. Then we're checking the data types. Do the data types of the B plus tree, the data structure, and of the row, do they mix up? Otherwise, it would be a little bit nasty. And then we take the table row, take the ID. 0 is in a row, the first element is always the ID. So I take the ID, and then here we need find row. So then we need tree, find row, temp by get value is 0. So what does this mean? This here gives us the actual ID. And when we go to find row, it's find node. Again, this here needs to do more testing. Yeah, that's a thing. There will be 1 or 2 sessions I do just writing tests for the whole thing. So this here is, you find the row. If no element is found, null is returned. Okay, so we're looking for a row. Ooh, there is a mishap. It's supposed to do this here. Okay. If there is already a row with this specific ID, we do not insert it. It has to be null because we do not want 2 IDs having the same value. And then we insert it into a row. So let's have a look at this method find row for a second. Find row just needs the key and returns the row. Here we have find node. Find node is not a good word. How are we gonna call this one? We're gonna call it retrieve row. Retrieve row data. Retrieve row data. I think that's better. So we need the node we start from and the key. So if the node is a leaf, then we know the node is a leaf, then we can cast it to a leaf. Then we are going through all the rows in that leaf and check if the ID is the same as the key, and then we return the row. If it's not a leaf, so if it's an internal node, then this is what happens down here. If it's not a leaf, then we are iterating again to the right element in this node. We cast or parse this node as an internal node. We're getting the children, the right child. We retrieve the index from this part here. We're getting the right child. Now we have this child. New node. Let's say child. So we're getting the right child. Then we call this method again with the child and the key. So we are traversing through the whole tree to get the right leaf. And if we found the right leaf, we return the row. That's how find row is working. Back to the inserter. So we find the row. If the row, so we're trying to find the row. Yeah. If it's not null, no, it has to be null. It was correct, actually. It was correct. If it's null, we can insert it. If it's not null, yeah, we have to find the row. If it's null, it's still empty because we are inserting it. We are not finding it. Yeah, it has to be null. It was correct. And and then we insert it. That's actually what I did in my last programming session. Now let me check if I did something more. Is there anything? Yes, there are some tests. It's like the inserter test. Yeah. I did some testing, but not, come on, a little bit smaller so it passes on here. Generating a tree we tested. So if this works, then if we could insert something, there should be no exception, but also no return value. Yes. Then it has the data row has the wrong dimensions. It has the wrong data type. And then we are having a print tree. That's when we just insert a single row, and here we are inserting like 5 rows into this tree. Let's run it. I hope it still runs. Output is a little bit, let's see. On level 0 on the root, we have the keys 3 and 5. On level 1, we have like the keys 1 and 2. They are to the left of the 3. Here we have the rows with the ID 1 and ID 2. On the right side of the root, we have the IDs. No. In the center, on the first level, we have the IDs 3 and 4, which are here in the center. There we have David Bowie and Paul Young. And to the right side of the tree, we have Elton John, like with the ID 5. So it actually works. I hope you had a good time watching this video. Next week we are talking about deleting rows from a table. Like always, the source code is tagged and you can find it under the video number. There is a tag, which for this video is version 003. Have a very nice week and see you next Sunday.